Hello my geniuses, welcome to another blood physiology playlist. So this is the first topic we'll be talking today on our blood physiology playlist. So we have our general physiology, we have the blood physiology, we have the excitable tissues, so you could go watch. We have the renal physiology and all specific about 12 part of physiology you could watch for your preclinical classes. So just go and check them out. But for this one, I'll be doing the blood physiology. I'll be introducing what the blood is, introduction to the blood, before we start most of the topic. So this is a secluded playlist of its kind. So the first question is, what is blood? So if you understand what blood is, it will be quite easier for you to navigate this section of physiology, because this will also lead to so many stuff like the CAVA, cardiovascular physiology, the respiratory physiology, the renal physiology, and all of them. So introducing what blood is. So what is blood? So an important thing you have to know that blood is a connective tissue in fluid form. So blood is also a connective tissue, but the only difference about it is that blood is liquid, so it's in the fluid form. So now if you want to calculate, we have about 5 liters of blood in the human body, again, which might vary with time. So 5 liters of blood in the human body, which contributes to about 7% of the total weight. You get TBW, total body weight. So we have 5 liters, we contribute to 7% of the total body weight. So it could be 10 different stuff. So blood could be 10 different stuff to different people. And it is very, very important that this concept gives us a real definition of what blood is. I say it's a connective tissue in fluid form and made up of 7% of the total body weight. So it is the fluid of life. So first of all, blood in your body makes you live, because so it's a fluid of life because it carries oxygen from the lungs, are you getting me, to other body parts. So if oxygen is taken from our environment into our lungs, for our lungs to our blood, for our blood to our tissues, so that is how it is a fluid of life. So CO2 is the used up part of oxygen from the tissues, which is delivered to the lungs down to the exterior. So that is why it is called the fluid of life. So it is a fluid of growth because it carries nutritional content that is needed for growth and development. So it's a fluid of life, and it also carries hormones from the endocrine system, and it gives us so many stuff. That's why it's a fluid of growth, and it's a fluid of health. So why is it a fluid of health? Because it protects us from diseases. So because we have the white blood cell, so the white blood cell contributes to 100% part of our cell that protects us from any disease that is coming through. So since you have understood this stuff, and it's very, very important, what are the properties of blood? So we are taking it little by little. So what are the properties of blood? First of all, the first constant you have to see that blood is red. So the color. So blood is red, but it is different in different vessels. So in the arterial and the venous, the color of blood is different. I get it now. So in the venous, in the vein rather, or in the venous system, the blood is what? Purple. Yeah, the blood is purple. You can call it purple red. You get it now. So purple. Why in the artery, blood is scarlet red? So blood is scarlet red in the arterial system. Why in the venous system, blood is purple? So you keep them for your exam. So what's the volume of blood? So if you could think about it, what is the volume of blood? So we have introduced what blood is. We're talking about the properties of blood. So the volume of blood is different. I told you when we are starting now, the average volume in a human body is 5 liters. Taking it small, 5 liters. But in a newborn baby, the volume is about 450. Yeah, it's 450 ml, not 450 liters. It's too much. 450 ml. You get it now. But one thing that it differs, because in female there's much more, 0.5 liters short, more than 5 liters in male, because of they go through the phases of what? Menstruation. So they lose blood much more. So about 4.5 liters in female, why 5 liters in male. So going to the next one is the pH. So what's the pH of the blood? So the pH of the blood is not static. It's about 7.25 to about 7.45. Yeah, now so it's a range. But some literature will tell you that the pH of the blood is about 7.4. So naturally it is slightly alkaline. The blood in the human body is not acidic, it's slightly alkaline. So another thing we have to know now, what is the specific gravity of the blood? The specific gravity of the blood, of the total blood, one thing for your exam you have to know, is about 1.052 to about 1.061. So the specific gravity of the blood. But it differs in blood cells and plasma, which we'll be talking about. Because the total blood is divided into the plasma portion and the blood cell portion, which we'll be talking about. So we have introduced the blood. We are talking about the properties of the blood. We have talked about the color. We have talked about the volume. We have talked about the pH, which is slightly alkaline, about 7.25 to about 7.45. So some literature will give you 7.35, or some literature will give you 7.4. So we have talked about specific gravity. So finally we're talking about the viscosity. So what is the viscosity of the blood? The blood is about 5 times more thicker, so it's 5 times more viscous than water. So very, very important, it's 5 times more viscous than what? Water. So the next we'll be talking about is the composition of the blood. So what is the composition of the blood? So the blood is made up of two forms. You have the plasma component, you get it now, and you have the blood cells. So the plasma component is the liquid part, while the formed element is the blood cells. You get it now? So we have the plasma component and we have the blood cell component. So what is the plasma component? So the plasma component is the stored color fluid of the blood. Are you getting now? And it's made up of about 71 to 72% water and about 8 to 9% solid. Okay, are you getting now? Again, it's a stored colored clear-like fluid of the blood, made up of 71 to 72% water and 8 to 9% solid. You get it now? So since you get it now, the solid component can be organic or inorganic. Organic is talking about the nutrients it gives us, like you have the plasma proteins, you have the carbohydrates, you have the fat. I'm giving you your screen, you still look at the picture. That these are the organic component. Why the inorganic component are electrolytes. You get it now? The electrolytes. Also you have gaseous components, which are also solid particles, but the gaseous component are not the water and they are not the solid. So we just have a little mega amounts that are gases. You get it now? So since you understand this side now, so now what about the blood cell components? Because we have talked about the plasma component. So the plasma component is a stored-like fluid. Now in the blood cell component, these are the formed elements. You have the erythrocyte, which is the red blood cell, which is about 40 to 45%. Now you have the leukocyte, which is the white blood cell, which is about 1 to 2%. You get it now, very small. And you have the platelets. The platelet is the last one, which is very, very small. Leukocyte and the platelet share the same percentage. You get it now? So very, very easy. So how can you differentiate? We call what we call the Hematocrit value. So you could see your screen, we call it the Hematocrit value. So how can you get the Hematocrit value of a blood? How can you separate the plasma component and the blood cell component? How can we separate it? Now, first of all, we have to take this into consideration. Take a test tube, put your blood inside, or take a sample of blood, put it into a test tube. Now you add an anticoagulant. Why are you adding anticoagulant? You do not want the blood to clot, so that's why you have add an anticoagulant, like you have warfarin, heparin. You get it now? So when you add them, first of all, it will not clot. Then you take the test tube, cover the test tube, and you put it in a centrifuge. So if you put it in a centrifuge, what happens? You spin the centrifuge. So centrifuge is a machine that spins so that the solid particle of any component will settle while the liquid component will float. So if you put it in a centrifuge, you try to spin it to a centrifuge. So when you spin it, what happens? The solid, more denser component will descend. That is the property of fluid. Denser particle descend while lighter particle will ascend. So the plasma component will float, will be on top, while the most dense, which is the red blood cell, will go to the bottom. Again, so it will go to the bottom at that point. While in the middle between the plasma component and the red blood cell component will be a medium part, we'll call the buffer coat. The buffer coat will be in the middle. The buffer coat contains the white blood cell and the platelet. So that middle is about 1.2%. So the plasma component is about 50%. Yeah, about 50 to 55%, while the red blood cell below is about 40 to 45%, while the middle shares about 1 to 5%. So that's how you get the Hematocrit value. So to determine the red blood cell component alone, we call it the packed cell volume. To determine the red blood cell component of a blood, that's what we call the packed cell volume. But what we have just done is a Hematocrit value, where we divide the plasma away from the blood cells. Yeah, so this is what I've discussed. So but if you are getting a serum, a serum is just the same way, but it's just that when you take a sample of blood, put it inside a test tube, and you don't add anticoagulant. If you do not add anticoagulant, what happens? It will clot. And if it clots, what happens? You get a cholesterol like fluid again, but now you are getting it from the clotted particle. So that clotted particle you are getting is what we call serum. So the clotted particle is fibrinogen. So fibrinogen has converted to fibrin, which has caused clotting. Because plasma protein, we have what we call plasma proteins. So plasma protein, you have albumin, globulin, and fibrinogen. So fibrinogen is the plasma protein that clotted. So what happens? It will come out as straw-like fluid called what? Serum. So serum is what? Plasma minus fibrinogen, which you are seeing on your screen now. So very, very simple. So the next thing we'll be talking about now is the function of the blood. So what can we say about the function of the blood? First of all, respiratory function. So what's the respiratory function of the blood? Because why? It carries oxygen from the surrounding or from the lungs to other tissues, and you bring out carbon dioxide from the tissue still in the blood. So the blood is just acting as a carrier. So nutritional function too, because the substance like glucose, amino acid, lipid, vitamins are carried all around to the blood. So when you eat, it enters in, gets absorbed by your ileum into your blood. You get it now? So from your blood it goes into your liver for what? Metabolism. So the next one is the excretory component. So the blood can also act as an excretory component of waste also. So from your skin, from your kidney, from your liver. So it can act as an excretory component. The next one is transport. So like I said, endocrines too. Their doctors gland which part their secretion into the blood carried out to a far distant organs for action. You get it now? So that is a transport mechanism for really hormones from the endocrine gland. The next one, it regulates water balance. So how does it regulate water balance? When there is excess water in the body, it's being excreted from the kidney, because the water is much more, apart from the tissues, ICF is much more lodged in the ECF, which is the blood. So when there's high amount of water in the blood, it tends to cause a cascade of physiological mechanism, which can lead to a host of physiological process which can be damaging to the body. So immediately the body excreted through sweat, or the body excreted through urine. So that is how the body balances water regulation. So it also regulates acid-base balance, yes, to plasma protein and hemoglobin, which we'll be discussing all in other part of our physiological playlist. So the next one, it has a defensive function. Why? Because it produces what we call macrophages, which are neutrophils monocytes, which undergo what we call phagocytosis, and there is presence of lymphocytes for cell-mediated immunity to help us defend the body from any form of attack, and also eosinophils to help us to guard the body from parasites and so many things. It also regulates the body's temperature. Like I said, excess water in the body, now, so the body removes it as sweat to parasympathetic nervous system, which we'll talk about. And storage function also, it helps you to store for when you need it. It helps you to store for a particular time. So I hope you understood everything I've talked about here. So I hope it all made sense to you, and you have understood everything I've talked about today on the introduction to blood physiology, and we'll talk about the blood. So after the blood here, we'll be going to the next topic, which is erythropoiesis. So you stay with me to the next topic, because I'll be explaining everything about erythropoiesis. So see you in my next video. Bye bye.